How's it, grade 11s? I'm going to be continuing with paper 1, 2019. So we're going on to question 9. If you can just follow with your, on your tablets with the question paper. It's a probability question. It's saying for question A, it's saying A and C are mutually exclusive events. If the probability of A or C is equal to 0.45 and the probability of A is 0.25, determine the probability of C. Okay, so we've got a few things going on here. First of all, they're asking for mutually exclusive. So I'm going to write down that formula first. So, and we're dealing with two events, A and C. So the probability of A or C will be equal to the probability of A plus the probability of C. That is mutually exclusive. Now you remember mutually exclusive, if we had to draw a Venn diagram, they're two events that have nothing in common. Okay, so we don't have that intersection bit. So you normally, you know, this formula would be, it would be this, but then plus the probability of A and C. Okay, but we don't have that because there's no intersection. All right, so that's mutually exclusive. They've also told us that the probability of A or C is equal to 0.45, and then the probability of A is equal to 0.25, and they want us to find what is the probability of C equal to. Okay, and as you can see from our mutually exclusive formula, we have the probability of A or C, so we have that bit. We have the probability of A, which is that bit. We can find out what the probability of C is. Okay, so that's all I'm going to do, is just substitute these in here. So the probability of A or C is 0.45 equals the probability of A, 0.25, plus the probability of C. So we just take the 0.25 to the other side and subtract, and we get the probability of C is equal to 0.2. As easy as that. Okay. Question B. If events X and Y are independent and the probability of X is equal to 1/3 and the probability of X and Y is equal to 1/12, determine the probability of Y. Okay, so again, we've got a couple of things going on there, which I'm just going to list like this. So they want us to find, well, they've told us that these events are independent. Now, independent events, the formula is the probability of X and Y will be equal to the single probabilities multiplied by each other. So probability of X multiplied by the probability of Y. That is your independent formula. Okay, they've also told us that the probability of X is equal to 1/3, and then the probability of X and Y is equal to 1/12. They want us to find the probability of Y. All right, so again, probability of X and Y, I have it. The probability of X, I have it. Probability of Y, that's what we want to calculate. So just substitute these in here and then you can solve for that. So probability of X and Y is 1/12 equals the probability of X, 1/3 multiplied by the probability of Y. Divide both sides by 1/3, so you get the probability of Y is equal to 1/4. Okay. Then question C. I'm going to do on a new page. Okay, so question C is saying, if the probability of A is equal to 0.55, the probability of B is equal to 0.35, and the probability of A or B is equal to 0.75, we need to find what is the probability of A naught or B. What is this equal to? Okay, so what I'm looking at here is we've got this, if I ignore the not bit, we've got this A or B, okay? And we've also got that over here, all right? What I'm looking at here is I'm looking at a Venn diagram, okay? And if I draw up this Venn diagram, and we can call this event A and event B, okay? Now, in order to find this A naught or B, so A naught would be nothing in A, so, and it would be everything that is B, okay? So it would have to be this circle B, but nothing in A. So it would be everything outside of this bit here. And that bit, if I can find my highlighters, one sec, I'll just use a red pen. So we're looking for everything outside that bit there. Okay, so we can't have anything inside there. All right. So what I need to do first is I need to find out what is this bit here, the A and B. Okay, and how we can find that is by using this formula here. The probability of A or B will be equal to the probability of A plus the probability of B, which you guys saw just now, okay? But because we have an intersection, we need to subtract the probability of A and B, okay? So that's what I'm going to be finding there, is that intersection bit. So we have the probability of A or B, there it is. We have the probability of A, and then we have the probability of B. So I can find out what that is. So I'm just going to be substituting in these values here. So we get 0.75 equals 0.55 plus 0.35 minus the probability of A and B. If I take everything to this side, we get 0.75 minus 0.55 minus 0.35, and we get negative 0.15 equals negative the probability of A and B. So that means that the probability of A and B is equal to 0.15. Okay. So what I can do now is I can fill in all my information. I'm just going to redraw this. Now, remember grade 11s, when you're doing these Venn diagrams, you always start with this intersection bit. So we know that's going to be 0.15. That bit there. Now, to get this bit here, I need to take the probability of A, which is 0.55, and I need to subtract this intersection bit, which is 0.15, and that will give me 0.4. So 0.4 is just that little bit over there. Likewise for this event B, I know it's 0.35. And I need to subtract the intersection, which is 0.15. And we get 0.2. Okay. Now, just remember, inside this box is your sample space. So everything inside this box needs to add up to 1. So what I'm going to do is I'm just going to see 0.4 plus 0.15 plus 0.2. And you see that does not add up to 1. So to find out what's left outside, it's just 1 minus that, and we get 0.25. Okay, so now our Venn diagram is complete. Now I can start answering this question up here. So the probability of not A or B will be equal to, now remember, it's everything that is not inside this little bit over here. Those are the numbers I'm going to be adding up. So it's 0.15 plus 0.2 plus 0.25. And we get a total of 0.6. And that is the probability of not A or B. All right, that's question 9.